Hello and welcome back. It's time for us to start doing some computing in our computer programs, and in this segment we're going to introduce the arithmetic operators that are available in C. There are 5 arithmetic operators: plus, minus, multiply, divide, and modulus. So the first 4 will be obvious to you. You've been using them for many years. In this little code segment that shows our first arithmetic statement in C, we have 3 variables declared of data type int: a initialized to the value 10, b initialized to the value 6, and result, which is an uninitialized variable. So the next statement, result, gets a plus b. A has 10 and b has 6. A plus b then is 16, and that's the value that goes into the variable result. So the arithmetic operator, the a plus b, on the right of the assignment statement happens first. And then once the result of that is calculated, the 16 is then assigned to result. So you can think of this as the assignment operator has a very low precedence. It will happen last, and the arithmetic operators have a higher precedence. Within the arithmetic operators, there is a precedence as well. So the plus and minus have a lower precedence than the multiplicative operators, multiply, divide, and modulus. So in this statement, result gets a plus b times c. What happens first? Well, the multiply has the higher precedence. So it happens first even though it's on the right of the addition. So b times 3 would be 18, and then plus a would be 28. So result would have the value 28 after that statement executes. You can use parentheses in C in your arithmetic statements to change the precedence. So result gets a plus b in parentheses multiplied by c. So the a plus b would happen first. And these rules of precedence are the same that you've been using in algebra, and they should be comfortable to you. Let's look at the modulus operator. The sign, the operator, is a percent sign. It has nothing to do with percentages. Sometimes people will call this modulo and sometimes just mod, but it doesn't have anything to do with percentages. People call this sometimes the remainder operator. 10 modulus 3, or 10 mod 3. Think of this as how many 3's can be taken out of 10 and what's the remainder. 10 mod 3 evaluates to 1. So we took 3 3's out of 10 with 1 left over. What's 11 mod 4? We can take 2 4's out of 11 with 3 left over, so 11 mod 4 is 3. 1,000 mod 10 is 0. I guess we can get 100 10's out of 1,000 with 0 left over. There are a couple of special cases using the modulus operator that you should be aware of. For example, if the left-hand operand is smaller than the right-hand operand. How many 9's can you take out of 6? Well, none. And what's left over? 6. So if the left-hand operand is smaller than the right-hand operand, the result will be what you started with. The next special case is when we have 0 on the right-hand side of the modulus operator. How many 0's can you take out of 15? Well, this is like a divide by 0. And at runtime, if you try to execute this statement at runtime, you'll get a runtime error. This is different from a compile time error, which happens when you are compiling the program before you even get to run it. So it's not a syntax error, it's a runtime error, an error that happens while the program is executing. Let's look at some more arithmetic expressions now. These can be arbitrarily complex, and a good programmer will solve their problems without writing programs that are too complex for other people to understand. So here we have 3 variables, a, b, c, initialized to 10, 4, and 5, and we have another int variable called result. All of these variables are only for the purpose of looking at arithmetic expressions. A, B, and C are probably not good names for variables because they don't indicate what the variable value is representing. So A, B, and C for now are just numbers that we're going to use to demonstrate arithmetic. So look at this arithmetic expression. Result gets A plus 3 times C modulus 2. What happens first will be inside of the parentheses. 3 times C, so 3 times what's in C is 5, so we have 15 inside the parentheses. Then what happens next? The modulus operator has a higher precedence than the addition operator, so we'll do the modulus next. So we have 15 modulus 2, and the result, did you get it? Yes, the result is 1. 15 modulus 2 is 1. And now add in A, which makes the entire result of that expression, or we say the expression evaluates to the value 11, which is then assigned to the variable result. The order that things happen in arithmetic expressions is critical to getting the right result and to understand what the arithmetic expression is actually doing. Here's another special case. All of this, well, you'd think I've been doing arithmetic for years and years. This is not too new, maybe except for the modulus operator. But we have one thing that's something that you don't come across in algebra until you're doing discrete mathematics or you're doing mathematics within whole numbers only. This is integer division. Think about the value 10 divided by 4. We have an integer division. 10 divided by 4 in integer data type is 2. There can't be a decimal point in the result. So one way that you can think of this is we have an integer operator, an integer division operator. We use the same symbol for double division. The same slash is used for double division, but if the operands are data type double, we'll have a different result. So 10.0, which is a double, divided by 4.0, the result is going to be quite different from 10 divided by 4. So an integer division versus a double division. Think of it as the operator itself has a data type, as well as the variables which are the operands to the operator. Let's go and look at some of these concepts, play with them in the development environment, and we'll also introduce the debugger during the demonstration. Okay, here we are back in the Visual Studio, and I encourage you to have your Visual Studio open, your development environment, and work along with me doing this. Let's work with the example as it was in the PowerPoint slide. So we'll make a variable A and put 10 in it, and B and put 6, and a variable called result that is not initialized. And then we'll say result gets A plus B, and we'll print out the result so that we can see that our arithmetic operators are working. So let's write A plus B is... Now we're going to output an int, so it's %i, and I'll put a carriage return and output the result. And a semicolon always goes at the end. Okay. Now F7 to build the project, and if you didn't get 1 succeeded, 0 failed, then you have to scroll up in here and look for your error messages. Ignore the warning messages for now, if you had any warning messages. And F5 to run the program. So A plus B is 16. So far what have we done? We've achieved adding two variables together that had the values 10 and 6, and we stored the result in this variable. Notice that in this line of code, the variable result changed, but the variables A and B did not change. So we have only two ways of changing the value in a variable. One is to assign it something using the assignment operator, and the other way is to input something into it. And we looked at the scanf in the last segment. So only two ways a variable will change, if it gets assigned something or something gets input into it. Okay, let's look at other operators. The multiply operator is the asterisk, that's shift 8. So A multiplied by B, and let's say F7 to compile and F5 to run, and the result is 60, which we would expect. Okay, now you can't put a percent sign here if we want to exercise the modulus operator, because inside of the printf a percent sign indicates that you're going to put a formatting string for ints or doubles or something else that we don't know about. So let's just put mod here. So A mod B is, so we have 10 mod 6. Remember that the modulus operator is the remainder operator. How many 6's can we take out of 10? 1, and we should have 4 left over. So let's compile and run this with F7 and F5, and A mod B is 4. So that seems to be working. Now, you can use, in your arithmetic statements, you can use variables or you can use literals. So I've been using variables in all of these examples, the variables we've declared A and B. We also might use literals. So if we put 11 mod 4, and I'll change the output statement so that it will look right. 11 mod 4 is result. So up until now I've been using literals, which are numbers in the code, and variables interchangeably without really talking about what they are. But they're completely different things. This is not a variable. It's a constant, a literal constant. So let's execute this F7 to compile it, and F5 to run it. 11 mod 4 is 3. Remember, how many 4's can you take out of 11? And what's left over? And that's what the modulus operator will evaluate to. More interesting arithmetic expressions have parentheses to control the order of execution. So if we write the one from the slide, A plus B, well, let's do it without the parentheses first. A plus B multiplied by 3 and F7 and F5 is 28. Let's see if that makes sense. B times 3 is 18. 3 6's are 18, plus 10 is 28. Now if we change the order of execution by forcing the addition to happen first, we should have what? A plus B is 16 times 3. 48. Okay, I want to just show you one more thing that I talked about in the slides, and this is one of the exceptional cases with the modulus operator. If you have a modulus 0, then we're going to have a runtime error, which will be the equivalent of a division by 0, which you can't do in integers. It doesn't make sense to divide by 0. So I want to make sure that you understand, first of all, that this program is syntactically correct. That means that it compiles without any errors. And now when we run this program, if I hit F5, what we'll see is we have an unhandled exception. it says integer division by 0, and it even gives us a yellow arrow pointing at what went wrong. And you might see down here that you have the value of all of the variables that are available to you. So it's very helpful. If this program were quite complicated, it's helpful to tell you what the runtime errors are. Okay, now, if you do execute a runtime error, you're now in the debugger, and you have to get out of this somehow. We're not in an editing environment anymore. If you look under the debug menu and say stop debugging, that will get you out of that and back to where you can now change the program. Okay, while we're here talking about debugging, I want to just introduce this briefly, and we'll do it again in another segment. You can execute your code one line at a time. So if I click over here in this gray margin, I have created something called a breakpoint. And now if we run this program using the F5, we'll run up to that breakpoint. F5 runs up to the breakpoint and stops. So the yellow arrow is now pointing at the line of code that has not yet executed. So we haven't come to our runtime exception yet. Now if we want to execute one line of code, or in this case attempt to execute one line of code, we could look at these new buttons that we have up here. We have one called Step Over, and that will try to execute one line of code. If this were a working program without runtime errors, it would execute one line of code, and we would see the new value of the variables down here. In this case, it's going to throw the exception, which is the integer divide by 0. And the only way to get out of this now is to do a stop debugging. Okay, I have not yet demonstrated any of arithmetic statements using our other data type, double. So let's declare a couple of double variables, double D1, and put in it 10.0. And how about D2? These are not good variable names, except we don't have anything really to, we don't have a real problem that we're solving. So I just wanted to demonstrate to you and have you type it yourself. I hope you're doing that. Is the difference between integer division and double division. So %LF, the result variable, is now a double, and D1 and D2 are doubles. And let's say D1 divided by D2, and we're going to divide 10 by 6. I'm going to turn that breakpoint off. No, let's leave it turned on. And we'll run to the breakpoint, and we'll see that result has this huge piece of garbage in it. D1 has 10.0, D2 has 6.0, and now when we execute that one line of code, result has 1.66666 and 7. So there's a limited amount of accuracy in our variables. This is in fact an approximation of 1 2/3, but it's a digital approximation, and we lose the accuracy about here. And when we print that out, let's execute one more line of code. And this is what was printed. It, by default, printed 6 places past the decimal point. And it decided to do a rounding there at 6 decimal places. We see that what's actually in the variable is more accurate than what was printed. It's not completely accurate, it's still an approximation of 1 2/3. This is a little bit disconcerting to people who are starting programming, that our arithmetic is really approximate when we're using decimal points. how approximate it is depends on what the data type is. In doubles, we have around 15 places of accuracy. So this is the last demonstration that we're going to do of these arithmetic operators. I encourage you to keep playing with them and see if you can make them do something interesting for you. Let's review the concepts from this segment. We have 5 arithmetic operators in C: plus, minus, multiply, divide, and the newer one that you maybe hadn't seen before, the modulus operator. You can also use the parentheses to change the order of operation within your expressions. The rules for doing this are the same as the rules you've been using in algebra. The additive operators, plus, minus, have a lower precedence than the multiplicative operators, multiply, divide, and modulus. So if these appear in the same expression, you're going to do the multiplicative operators first. The percent sign is used as the modulus operator. It has nothing to do with percent. There are a couple of special cases. One of them that causes a runtime error is when you do something modulus 0. So if 0 is the right-hand operand of a modulus operator, you're going to have an error at runtime. This is while the program executes the statements. When it comes to this statement, it cannot execute it, and it will give you a runtime error. Operators have a data type based on the operands that are being used. So we looked at the condition of an integer division versus a double division, or an int division versus a double division. In int division, we have only whole numbers as the result. So an int divided by an int is an int. And the example we looked at, 10 divided by 4 is 2. Double division, using the same arithmetic operator, doesn't have this issue, because the result of a double division will be a double. So you might think of this as, in an integer division, some information is lost. You might think of it as you get the wrong answer, but that's what int division is. A whole number divided by a whole number is a whole number. And the issue, the last concept that we looked at, the issue of precedence, the multiplicative operators, multiply, divide, and mod, have a higher precedence than add and subtract. It's a good idea to play with these operators in your C development environment, and hopefully you've been doing that along with me by pausing the presentation and then typing and going back. It's a good way of learning it. It's especially if you're sitting alone, it feels as though you have someone that you're working with. Hope you're enjoying it. I'll see you in the next segment.